Hi, this will be my final talk about the Collatz conjecture, the 3x plus 1 problem. I believe this is the 10th video I've made. All of them are 5 minutes, so they're not too painful to sit through. This one I'm just going to address the second half of the conjecture in a very superficial way. It's much harder to prove than the first half, and what I'm going to suggest is a couple of things. What you're looking at here is the congruence of input and output numbers, and so the ABC here corresponds with the three operations in this function. A is mod 4, B is mod 8, and C is otherwise. I'm not going to explain any further what this means, as I've already done that, but so one operation is times 1.5, one operation is times 0.75, and one is times 0.25. That's all I'm going to say. So we do see that there is a 16-unit repeating cycle, which is rather interesting. It's constant. Every 16 units we see the same thing repeating itself, and those are the output. Those are the output congruences, and whenever you see something in a steady state like this, it strongly suggests that based on those three multiplication operations, there cannot be continuous increase. And because 2 out of the 3 operations reduce the number, the likelihood is that it has to come down to earth sooner rather than later. Unfortunately, this is only a probabilistic argument, but it's a pretty convincing one. You cannot have these numbers in a steady state because they will because they can't repeat each other. The set of numbers will be exhausted. And I would just observe some interesting things also related to congruence, in that taking the largest, the operation that multiplies by 1.5, you see, if you look at the odd numbers and add 1, that factors of 2 decrease with each increase. And when you run out of factors of 2, and you're losing 2 with each operation, when you run out of factors of 2, you can't continue with the increase operation, with the growth operation. You have to switch to one of the others, which reduces the size of the number. And just in case you don't get why the factors of 2 are decreasing with growth, it's because it's not growing by 2, it's growing by 1.5. So two factors of 2 are being replaced by one factor of 3 with each growth operation. Similarly, there's somewhat similar properties for the other 2 operations concerning the factors of 2. When you put it all together and you look at a sequence, a substantial one, you see that the factors of 2 are changing all the time and seem really to be controlling the growth. There's a nice example here. You see how the factors of 2 are diminishing with each of these operations, and then it has to switch to a different congruence class. Here you see that when you do switch from A to C, or sorry, you switch from C to B, your number is obviously a quarter, but you're getting all these extra factors of 2 with which you can grow again, potentially, not in this case. So you see how key the factors of 2 are. Thank you.